It is.
So as Eric alluded to, I'm talking about Canada1Water Phase 2. This is a progress report for the fiscal year that ended at the end of March. And we're looking at a number of components. So to acknowledge my co-authors, Melissa Bunn and Steve Fry, who are both co-leads for Canada1Water. We don't need to walk through this, but should you ever access this presentation in the future, this will give you some insight into the background of the project. We have a great multidisciplinary team that is laid out before you right here, based on discipline, and consists of both private sector, government, and academic contributors to Canada1Water. And just to highlight the co-authors, then you can see Melissa Bunn right here, and Stephen Fry to the left under HGS modeling. So for those of you who are not familiar with Canada1Water, and I can't believe that anyone is not familiar with Canada1Water by this point in time, we set out to ambitiously model the water cycle of Canada. And the reason for that is that water is a fully integrated cycle, and we were interested in coupling the numeric modeling of groundwater, surface water specifically, and to utilize wherever possible natural forcing boundary conditions, whether those are physiographically defined or whether they're atmospherically, climatically defined through precipitation, temperature, etc. And this just elucidates a little more the framework that we've implemented. And if you're not familiar with Canada1Water, you can scan the QR code on the right-hand side. And there's a very comprehensive 45-minute presentation for World Water Day 2024 given by Stephen Fry for the Canadian Water Resource Association. So we spent the first 3 years compiling data, harmonizing, classifying, and attributing data sets to support the numeric modeling, and also building a regional climate model. So taking global climate models and downscaling those to a regional footprint, and with the University of Toronto. And then the integrated groundwater surface water modeling, hydrogeosphere. Let's see, here we go. So phase 2, what did we propose to do in phase 2? Where have we run amok and diverged from the promises that we made to our dedicated reviewers and providers of funding? So we identified 7 key elements, a continuation of phase 1, indicator review and development, GRACE water budget trends, water budget closure for Canada, modeling and water indicators using GRACE and the C1W framework, base data enhancement and communication. And you can see on the right, the red tick marks are where we're on track, and 2 items are not conforming to our plan. And we'll review why we postponed item 2, and time just doesn't really allow us to address item 6, which we decided was maybe not central to this presentation. So, and on a broader front, where does Canada1Water fit into Canadian government priorities and objectives? And here are 6 items that we were asked to identify how we supported them. And I'm not really going to talk about these today, though we will touch on a little more on the federal sustainable development strategy in the next slide. And NRCan has a number of items in the federal sustainable development strategy, which is a subset or reprofiling of the UN Sustainable Development Strategy, SDGs, specifically for Canada. And you can see in the lower right, NRCan in 23-24 highlighted the items in black there, 4, 5, 7, 8, 9, and so on. Interestingly enough, number 6 is not in the list, which is clearly where we strongly align. But we are also strongly aligned with 4, 7, and 13, along with 15. And we will touch on some of those intersections in the presentation. So where are we in the scale of delivering results from the numeric HGS hydrogeosphere physics-based, fully coupled groundwater surface water model? And we are still in the late stages of calibration. We had some hiccups following the end of phase 1 with changes to the forcing data, which required some calibration to be revisited. This map on the left highlights just the water basins and the calibration stations. And more specifically, this table, you can see the basins defined on the left. There are 7 basins. You can see the status. The green highlights the complete ones, the number of surface water calibration stations, and the performance related to I gotta forget what NSE stands for, but I'll jump over that, and percent bias. And you can see for the complete stations, they're quite close to the total number of stations for both NSE and percent bias. And the 3 outstanding watersheds, the Atlantic at the top, Nelson and Pacific at the bottom, were converging on the number of stations. The Atlantic is close, a bit more work in the Nelson, specifically for NSE, and Pacific is pretty well complete. Just a few of the low order streams in the mountains that provide flashy flows remaining to be dealt with. So we're anticipating that we should be reporting results this fiscal year. We continue to release underpinning data sets. So the hydrostratigraphy, we've released the Canada1Water version of the National Hydrologic Network. We have reviews completed on soils and a enhanced digital elevation model. One of the peculiarities of the DEM to support HGS is that it needs to have lakes in it. As HGS is a control volume model, we need lake volumes. And so we processed, unfortunately, in parallel with the development of the medium resolution DEM produced by CCMEO, our own medium resolution DEM with lakes in it. And we have in review bedrock superficial geology and depth to bedrock. So hopefully by autumn, we will have all of these through the review and publication process. We continue to develop nested models. That was a component of phase 1, and it's continued in 3 different components in stage 2. On the left, transboundary watersheds, or as an example, Rainy River in Western Ontario. The model underneath is the caricature model in the Mackenzie Basin, not actually a transboundary, but neighbors, the Yukon. We've developed a high-resolution model for the province of Nova Scotia, thanks to the awarding of a strategic fund investment by the GSC to advance that work. And through an MOU with Environment Canada, we have been modeling select watersheds for their Natural Smart Climate Initiative. We did a proof of concept on 8 watersheds with a standardized methodology that could be upscaled across ecoregions and their study sites. So they have several thousand study sites. So the exact methodology for that eventual implementation remains to be seen. We continue to release data through the Canada1Water data portal. and you can currently download quite an array of, or you can visualize quite an array of data. You can only download data that's already being published, which currently limits downloads to watersheds and an NHN data set. But we're making progress along with the GRACE data set, which I'll touch on in a minute. Indicator review and development then was deferred or postponed for strategic reasons in favor of work on the 3 items presented here. Review work contributing to the National Freshwater Science Agenda. Development of a field trip guidebook to accompany the IAH meeting in Ottawa last week. And then working with the Canada Water Agency to coordinate and develop a panel discussion on groundwater science and policy in Canada, and to subject our leadership to questions on the challenges of jurisdiction, funding, and capacity. So we touched on the data portal earlier. We've, with the Surveyor General branch of Canada, we've operationalized their solution for GRACE through the data portal, and it's processed based on the 70 watersheds you see on your screen here. And within the data portal, you can actually interrogate any of the 70 watersheds, and you will get a time series graph of the 20-year record of GRACE, 22 years, though there's a lapse of 18 months to 2 years, so we can decide what the exact time period is. And you can download those results based on watersheds also. You can also change the length of the time series. The graph here just highlights a northern Quebec watershed flowing to Ungava Bay, and a loss of permafrost massive ice with time. Continue to work with Su-Shin Wang at the Canadian Centre of Mapping and Earth Observation on GRACE solutions, and we have a paper in review at the moment on the standard spherical, harmonic, and Masson solutions from JPL. That's the graph on the right just highlights the loss of water over the 22 years from the Pacific coastal drainage region, and Su-Shin's solving for slightly different watersheds than the 70 previewed previously. We're also working on modeling the GRACE data. As you may be familiar, GRACE lags the current date by 3 months approximately. And so we're hoping to use HGS results to infill that 3 months and forecast the GRACE signal to the current day, and with some hard work, by the end of the program cycle, hopefully actually maybe make a forecast 2 to 3 months into the future. Maybe not so critical for groundwater, but interesting for other components of the GRACE signal in terms of soil moisture, surface water. So the team has been active. We've published 5 journal papers. There's 3 in review. GSC publications from a data perspective are progressing. We submitted 15 abstracts, presented on 7 of those, made 14 non-abstract related presentations to government departments or universities, etc. Signed 3 MOUs with universities, 2 with Environment Canada, 1 specifically related to the Nature Smart Climate Solutions Initiative. And our top data request continues to be the Canada1Water version of the National Hydrologic Network. So in summary then, we've operationalized GRACE for 70 watersheds, made the data available, initialized work on Nelson River forecasting for Grace. And that's was very much advanced due to strategic investment funding from the GSC Director General. Advanced collaboration with ECCC and Ag Canada and universities to enhance additional analysis of the Canada1Water framework and data sets, and successfully advanced the communication initiative. So thank you very much. I think that's it. There you go. If you want to reach out to myself or Melissa, there's information. If you want to go to the portal or the website, the QR codes are on the right. And if you want to read the Phase 1 summary report, it's open file 9190 from the Geological Survey of Canada. Thank you very much.